Welcome to Inside Builder channel, large language model automators, Python enthusiasts, and my dear friends. DSPy Signatures. Can you tell me about it? If someone asks you that, this video is going to be the answer. Before we jump into what, how, and what the signatures are made of, let us first of all understand why there is signatures module or why there are signatures in DSPy. DSPy takes a modular approach, and signatures are the building blocks of that modular approach. Signatures are used to create prompts using variables that we provide through the signatures. It is used for optimizing the prompts. It is used for actually getting the best results out of the models using the data sets that is going to be discussed later in the coming videos. Each and every NLP task can be implemented as signatures with just 3 or 4 words. You'll be seeing that, and then it can be optimized further. It can be used, the signatures that is, can be used with various modules like predict, ChainOfThought, react, ProgrammOfThought, multi-chain comparison, and majority, which we will look at in the next video. Modules are something that you have to look and study very closely because they are the building blocks after signatures. Fine. Now let us go up and let us see what are DSP signatures. So it's a template of prompts to which fixed inputs and outputs are provided. These signatures define and control the behavior of modules that follow, and they contain field names. All these things are the signature characteristics. Now, what are the parts of the signatures? So before we dive into the parts of the signatures, there are 2 kinds of signatures. One is inline signature and another is class-based signature. In case of inline signature, it is used directly inside the modules like the module that we spoke about in the bottom, like predict, ChainOfThought, react, etc. And there are class-based signatures that you manually create. We will be seeing that how to do it by inheriting signature class. We can build it, but this class-based takes a more detailed approach. We can clarify what the task is about by using the Docstring. We can supply the nature of the input and the constraints on the nature of the output fields. So all these things we can provide in the class-based signature. All these things might look a little abstract, but we are going to dive into the code in a couple of minutes and it will all be clear. Now, how they help in programming LLMs. As you can see here, signatures can be represented as classes. That means it can be assigned to variables as objects, and it can be modified programmatically, which means that the prompts that are going to be created inside the signatures can be, yes, you are going to hear me right, it can be optimized. This I already discussed in the earlier videos. It can be optimized. So how that is going to be done, you have to understand the signatures first. If you don't understand how this building block is happening, then once you're going to evaluate, once you're going to compile, it will not be clear. So that's why, I'm diving into this, and even in fact, I am making smaller videos because I want you guys to, understand this quick and take this single notebook. So this single notebook contains all the modules, in fact, in a single notebook, and you can try it out. So that's it. That's it about the intro. I think I've done a good introduction. So let us move forward. Let's start walking through the code. We are going to use OpenAI GPT 3.5 Turbo. I keep this as cheap as possible so you guys can also try it out without any kind of inhibitions. I have been trying these examples out with less than 0.05 or $0.1 US spend. So I think it's worth it, guys. You should try it out. I am going to use OpenAI class signature following that predict, ChainOfThought. Apart from this, I am also going to use a couple of more classes called as input and output fields, which I will show you in a couple of minutes as we walk through. Next, I'm going to import the OpenAI SDK and assign the OpenAI API key through the environmental variables. I need to import print from Rich. You'll see that in a couple of minutes. Why? I am instantiating the OpenAI language model here and assigning it to Turbo. This is something that I dove into deeply in the earlier videos. I'll be attaching those videos also along with this. Take a look at that. And comes signatures. Signatures comes in various sizes, various formats, etc. What you're seeing here is a kind of Python object, it's a dictionary, but this is how I take notes. So whenever I learn something, whenever something looks that can be placed into a dictionary, placed into a list, then I do that. What happens is once you actually type it out, and by creating these kinds of key value pairs, you will exactly know that you can use them in your future programs. If you are going to show it somewhere, if you are going to create a presentation or a Streamlit app, like in the last videos I had showed the transformers, just a second, the transformer universe app that I had spoken about. So this app came into picture because this entire app I had learned from the notes or documentation that has been provided by Transformers library, and then I decided, okay, let me create some kind of list and dictionary data structures out of it. And once I created it, then I thought, okay, let us actually put it in a Streamlit app and I can share it with others. I mean, your notes are very, very important, and apart from that, your notes has to be useful for others also. I mean, and moreover, if you are not ready to do such kind of manual work, you can still use the large language models, and you will see how to do it today. Let's dive back into the notebook. So here you see that there are a couple of key values like question answering. The task will be represented like this. So there is a question and there is an answer. So that is how the task is represented in the signature. Sentiment classification, there is a sentence and there is a sentiment. In case of summarization, there are various ways, like you can give document, you can get the summary, you can give a text, you can get a gist. So you can see the pattern here. The names that you assign to the fields, these are all the fields that are going to go into the signature. These fields have semantic meaning. They have semantic syntax that gets assigned to it as it goes into the signature. And following that, you have RAG, that is the way to get the questions answered from the context that we give, and also multi-choice. So in this case, you have the context and question followed by the answer. And in case of multi-choice, you have question and choices followed by reasoning and selection. So all these kinds of signatures you can create, and you can do that inline. So what is inline? The inline signatures are something like this. You have to import this predict class. I already done at the top. And once you import this predict module, it is called as module in DSPy. And this predict module, you can send this signature straight away. And this will internally use to create the prompts. So how it is being done. So once you execute this particular cell, what will happen is it will in fact create an object. It's a predict object, and this predict object will contain something like this. So you see, it is having a signature which is named like this, and the instructions given the fields question, that is this question, produce the fields answer, that is this answer. So this is what I was talking about. The names that you give for the field has meaning inside the prompt, and following that, each of the fields is of type field, and it has annotations like string, it is required or not, and also most importantly, you can describe the constraints and the characteristics of inputs and outputs. So here there is no any description, but we will see in the next how to create descriptions also. So this is question answering task that has been converted to predict object, and here there is document summary. You can see the same thing. So that is document summary, and given the field document, produce the field summary. Here the prompt is not telling to summarize. Did you realize that the prompt by itself is not telling? The prompt is just telling that given the fields document, then just produce a field summary. So the term document and the term summary will be having meanings inside the LLM context when it is sent to the LLM. So that is what that is the reason why you need to create the field names appropriately. You cannot expect a summary when you are going to just say something like a theory. So if you say, instead of summary, if you say theory, then you can't expect a summarized output. So you might actually expect something altogether different. I want you guys to try with different kinds of names or terms here. I'll be showing you a couple of them that I have tried in the bottom. So you can see that is one thing. So using predict module or the predict class is one thing, and there are other classes called as other modules that is called as chain of thought. So this is one of the challenge that I faced with DSPy. there are modules in Python, and there are modules in DSPy, and there are classes also. So this chain of thought is actually a class inside the DSPy library, and it is called as a module. Again, I am repeating, this is a Python class that is called as a module inside DSPy. I'm going to fix something now. I'm going to call these things as classes, Python classes. It is much more easier and much more formal, and I feel that it will be easier for me to communicate. So bear with me, guys. All these predict, chain of thought, even though they are modules inside DSPy, it will be called as Python classes from now on. Anyway, continuing further. So here I am doing chain of thought, calling the chain of thought class, and I am sending this document summary signature, and you can see that a chain of thought object is created with the signature, and nothing changes here. Whether it is a predict object or a chain of thought object, the internal details, the instructions are same. So how the end module or the end model will know what to do, how to use chain of thought. So these things we will discuss in the next video, where we dive into the chain of thought, predict, program of thought, classes in detail. Fine. So these are all the ways to look at the outputs. Now we are going to develop custom signatures. If you don't like these simple looking document summary and simple looking text gist, all those stuff, then you can make it a little more complex. So to make it a little more complex and also much more controllable, you have the class creation option. So you can create your own signature classes. So here I have created a multi-class signature inheriting the signature class. So if you are not from the Python background, don't worry about it. What I am trying to do here is that whatever I have done here, whatever the signature that we have created here using three words. I mean, there is document, and this is actually a word, and then there is summary. So these three words are created with much more additional details like classify. So here I am going to give the task that this particular signature is going to do. So classify the given data into address, human's name, location, building, amount. So this is what the this particular multi-class will do. And the input field data to be classified, that is a description of the input field, and the input field is called as a sentence. So this is very important. So when you are going to give input or give your data to classify, you have to name it as sentence, and the output will be of data type. So that's how it comes, and the output has to fall into one of the categories that I have listed here. This is very similar to ZeroShot classification that you will find inside the Hugging Face Hub. If you guys are new to Hugging Face Hub or Transformers or any of the NLP tasks, you can take a look at this this particular page where I explain about it. And also this is a Hugging Face Hub space. You can go to the this area. I think I forgot where it is. You can actually go to Hugging Face Hub main space, and you can start going into the excuse me, just a second. So you can go into the docs, and inside the docs you will get all the necessary details. So let us go back. So we are coming back. So here you are going to use the multi-class that we created, this particular multi-class, and we are going to send it to predict. And the moment we do that, the new kind of pred underscore class object will be created. And here you will see it is much more detailed. Here the instruction says that classify given data into address. So here is the instruction is different from the instruction that you saw at the top here. So the instruction here contains document, summary, etc. But here it is exactly the docstring that we gave. Following that, the sentence has a field and it has the description also. So you can see that here, the description that we gave here comes here. All these things are going to tell to the large language model that how to work with this particular signature. Okay, this is a signature that I created for the prediction process. But in order to create this, in order to show you an example of address, human name, location, building, amount, etc., I can manually create these addresses, human names, etc. But I decided, okay, why to do it manually? Let me do it through LLMs. So this is one of the power of working with DSPy. So I created one more predict object, and this predict object takes required data and it is going to give me JSON output. And I'm going to give a prompt. Provide one example of address, location, human name, building name, and amount. And this is going to be my required data. And I'm going to expect a JSON output from the large language model. And all these things I'm going to build it using the DSPy predict class. Once I do that, I use the get JSON data, the required data equal to prompt. So the required data is going to be equal to this prompt. And believe me, the output is JSON output. It's as simple as that. I did not actually tell what kind of JSON output, but I can do that also. If you guys can explore it, so you can see the JSON output here. And moreover, this JSON output is properly formed. What I mean by that, if you import JSON from Python library and if you load the JSON object using json.loads and call this output response.resp is response.json_output, you will actually get a dictionary, a proper dictionary that can be worked with inside Python ecosystem. So that is the power of DSPy, and that is the power of signatures. Like you see here, I am introducing signatures, but in order to introduce the class signature, I had used inline signature to create data and then use that data to show how the signatures work. In fact, all these things I have done it in matter of 15 to 20 minutes. So this is possible, guys. I did not do a lot of prompting. I know this data is not perfect. Once you start putting this prompt into LLMs and try to get actual data, it is going to be different. It's not going to be same. I agree to all those points, and there are answers to those in the coming videos. How to improve the output from the prompts, it is possible, but you have to still understand the logic and understand how the things are working in the backend inside the DSPy signatures. So signatures are very, very important. Moving forward, so here I am calling so what I've done is basically I've taken the values that I've got from, just a minute, it's better that I show you what has happened here, because it's actually easier to show rather than to explain, as I always say. So if I run this, you will see that it gives me a array of list of values. So that is this value: 123 Main Street, New York City, John Doe, Empire State Building, etc. And I'm going to run a for loop, and I'm going to send this through the pred_class. That is the multi-class classifier that I created. So this one, I'm going to send it through this predict object. Excuse me, but sorry about the voice. And there I'm going to send these values one by one, and I'm going to ask it to predict, and I'm going to get the data type. So the input is sentence and the output is the data type. So you see that I'm using that, and once you execute that, you will see that I'm classifying this particular sentence 123 Main Street, and it is classified as address. I'm classifying New York City, and it is classified as location. It's not classified as city because I have not asked it to classify as one of the classes. City is not one of the classes. Again, John Doe is human's name. Empire State Building is a building. It has a building in it, and $100 is an amount. So you guys have right now seen how you can use signatures not just to do NLP tasks, but also to get data from the large language models in the format that you want. Apart from that, all the NLP tasks that you see here has been converted to generation tasks. We also saw how you can use class-based signature creation and how the internal signatures are created in as predict or chain of thought objects. Also, we understood the various types of signatures that you can use for inline signatures, which is very intuitive, but only when you use it with your own words, with your own different meanings and different synonyms, then you will see how the LLMs are functioning. Here, important point is I have not used any open source LLMs. You can actually try to work with open source LLMs. I have updated a video on connecting with Olama servers and also through HF modules, HF models, Hugging Face models directly without any kind of hassles. It is possible, guys. So take a look at my earlier video and you will see that testing the same thing that I've done here is super simple by using the HF client and Olama local client or Olama local class in DSPy. So do take a look at that, try it out and see how the models are working, how those open source models are working in comparison to OpenAI. It's a very good exercise, and that exercise is not going to take you more than 10 to 15 minutes. That is a key aspect. Whenever you're learning, you should learn really fast. You should see the output immediately. In that way, you will keep on learning. So that is one way to stick to your routine. Also, the final point that I want to make is that always understand the why. We understood why signatures are there and how signatures are helping in the modular approach of DSPy, how they help in optimizing the prompts down the line during the evaluation and the compiling process of the modules. I have not discussed about those things, so stay tuned for that. In the next couple of videos, I will be discussing that, how we can represent signatures as NLP tasks. That has also been discussed. So all these points, I believe that you have learned a thing or two. So leave a like, and if you have any questions, do leave a comment. I am trying to cover all the bases. I am trying to give you examples that can make you intuitively understand what is going on. And if still you are facing some challenges in the notebook or in the way I am telling, do leave a comment. I will try to provide the feedback over the comments. So with that said, I would like to close this video with 4 words: start practicing, start practicing. See you guys. Have a great time.